Raju, please tell them to join quickly because it's already.
Yes, sir. Yes, sir.
Okay, can everyone hear me? All of you? I hope so. So let's start the schedule.
Okay, sir.
We have already discussed about the thermodynamics. I don't think so there is any problem. Shall I start with a new chapter or do you want anything to be discussed in thermodynamics? See, Sadhu sir is completing the chemical kinetics. I'll be taking the acid phase and electrochemistry separately. Though
Okay,
electrochemistry,
sir.
some notes have been already provided, but I'll be taking the acid base and the electrochemistry portion. And so we will be completing it by this weekend, by next weekend at least, we will be completing the three of the all the units. So I want to know, do you have any problem? You can write in the WhatsApp also. If you have, shall I need to discuss once again the thermodynamics in brief? Do you want me to discuss and then go to the next chapter, or do you want me to start the next chapter?
So if you just in a little brief, if you revise the thermodynamics, that would be better then.
Okay, okay, fine, fine. So I will be taking up to now. I'm locking the meeting. So I will be. So uh,
হ্যালো স্যার।
yes, tell me.
স্যার আপনি আগে যে আইডি পাসওয়ার্ড মানে আইডিটা দিয়েছিলেন ওটাতে অনেকজন ঢুকে জয়েন করেছিল আর কি, তো আমি এখন বললাম ওটাতে না জয়েন করতে, নতুনটাতে করতে। তো একটু ওদের ওদের 4-5 জন আছে মনে হয়, ওদেরকে একটু অ্যাড করে দেবেন জাস্ট।
স্যার
আমার কাছে এখন yes, tell me.
স্যার বলছি আমাদের যে বইটা লাইব্রেরি থেকে দিয়েছিল না কেমিস্ট্রির, ওখানে না ওই অর্গানিক কেমিস্ট্রি চ্যাপ্টার গুলো না নেই। তো স্যার আপনি কোনো একটা বুক সাজেস্ট করবেন যেখানে আমরা তাহলে পিডিএফটা নামিয়ে নেবো বুকটার। অর্গানিক মানে
অর্গানিক কেমিস্ট্রি এখন কেন চিন্তা করছিস? এখন তুই অ্যাটলিস্ট ফিজিক্যাল কেমিস্ট্রিটা শেষ হোক, তারপরে অর্গানিক কেমিস্ট্রি শুরু হবে। অর্গানিক কেমিস্ট্রি ফিনারের বই আছে, অর্গানিক কেমিস্ট্রি অনেক বই আছে। অর্গানিক কেমিস্ট্রির মধ্যে তোদেরকে যেটা পড়তে হবে হচ্ছে স্টিরিও কেমিস্ট্রি আর রিঅ্যাকশন মেকানিজম।
তাহলে একটু পরে বইগুলো বলে দেবেন।
আমি বলে দেবো, আমি বলে দেবো।
থ্যাংক ইউ স্যার।
Right? Hello. Yeah. So meeting is locked. Now there are 45 participants. So as he said to me that you want some revision of thermodynamics. Already we have done a lot of thermodynamics. Now coming to the, I want to take you to the. Can you see the whiteboard?
Yes, sir.
Okay. So I'm actually not conversant with this type of. I don't know where it starts writing. Anyway, I got it. So some important formulas for thermodynamics to wrap up the thermodynamic portion. Now this is going long. Okay. Now if you see the thing that can you hear all of you can hear me?
Yes, sir.
So, important formulas to understand the thermodynamics. So what are the important formulas? The important formula number one is whenever you want to find out the work, then you use the formula work W equals to this we all know P in dV. Now the most important thing is the second point is work cannot have any sign convention. Always remember, whenever you are doing the numerical, please remove the sign convention from the work. Work cannot have any sign convention. The third point that we have to say, according to the first law, in adiabatic condition, what are the things that remains constant? In adiabatic condition, Q that is remain constant, and that is why we say attribute mathematically Q equals to 0. Am I clear? And in isothermal condition, whenever we say isothermal condition, in isothermal condition, we have the temperature is constant. Now, if the temperature is constant, then the internal energy U also shall remain constant. And if U shall remain constant, then it becomes equivalent to 0. Up to this much, any problem, please tell me.
No, sir.
So,
Shall I proceed?
Yes, sir.
Now, according to the first law of thermodynamics, what we can write? According to first law of thermodynamics, what is the first law of thermodynamics? We say that Q that is equals to, now that is I cannot write delta U, so it is I am writing dU plus this is the work. So if Q remains constant, that means in adiabatic condition, what happens? Q is equal to constant. So if Q is constant, that means that is equal to 0. So in that case, you cannot change the W to be negative. So I side change the du equals to that is W, where W is again given with the expression with PdV. Now, for example, conversion. Now, if it is in isothermal condition,
Sir, are you writing all this? Excuse me, sir. Are you writing all this in the screen?
In isothermal condition, so it becomes Q equals to W. Now, the point which I want to reflect is the conversion factor. Just hold a minute, please. Hello.
Yes,
Hello.
sir. Yes, sir.
Someone was saying something.
Actually, sir, you are
No, we can see that.
No, you are saying something.
sir, now we can see. It's okay.
Can you see it right now? So
Yes, sir.
now, so the conversion is, suppose I have a conversion factor of something like 10 liter atmosphere. Suppose if it is 10 liter atmosphere, I need to convert it into joule. So to wrap up, I have to multiply with 101.3 joule. That is what is called 1 liter atmosphere. That is 1 liter dot atmosphere is equivalent to 101.3 joule. And the other factor that are predominant is the gas constant factor. The gas constant factor, as I told you, in the numericals also you have seen, it is given as in CGS system, it is given 1.987 calorie per mole per Kelvin. Whereas in SI unit, the gas constant is given as 8.314 joule per Kelvin per mole. Another thing is that if you want to convert anything with, for example, liter, then you take the R value as equal to 0.0821 liter dot atmosphere per mole per Kelvin. So I have given the three factors of the R value. One R value is 1.987 calorie per mole per Kelvin. This is in CGS unit. The other is 8.314 and the other is 0.0821 mole per Kelvin. Okay. Have you understood up to this much? Shall I proceed?
Yes, sir.
Then
Yes, sir.
we have your we know that we have CP and the other factor is CV. We also know that this CP is equal to CP minus CV, that is equal to R. From this relationship, I can find out CP equals to R plus CV. Now, if you want to find out the CV value, CV for monoatomic gas, this is very important, monoatomic gas, that is equal to, it is 3 by 2 into R. So, whenever you will be doing any type of example, it will be 1.5, either you multiply with 1.5 into 1.987, or you can also multiply 1.5, you multiply with 8.314, or also you can multiply 1.5 into 0.0821. Now once you get this, so you can find out the CP value. CP value can also be written as CP equals to, when it is R, R can be taken as, if you are taking in calorie per mole per Kelvin, it is 1.987 plus your 1.5 into 1. Can anyone calculate for this? 1.5 into 1.987 is how much?
Excuse me, sir. We can't see anything after the, you have written the value of R.
Can you see right now?
Yes, sir.
Can you see?
Yes, sir. Yes, sir.
Okay. So it is, as I was writing over here, so it is so it will be, so I'm writing once again, CP, can you see right now? CP equals to 1.987 plus, what will be the factor of 1.5 into 1.987? 1.5 into 1.987, that is equal to 2.985. 2.98, or you can take 2.9805. So you can take 2.98 or 05, that is equal to something around 4.98. So approximately this is equal to, it is approximately equal to, you can say 5. Now if you take 1.5 into 8.314, now if you see that it is 1. CP value equals to 1.5 into 8.314, then this is equal to, so it will become 1.5 into 8.314, that is equal to 12.471. So it is 12.471. Now, when I am writing this, if you are multiplying with 1 mole, then it becomes, the unit will become, it will become equal to 12.471 joule per Kelvin. Have you understood up to this much? Hello?
Yes, sir.
Have you understood up to this much?
Wait a minute. Yes. Okay, sir.
So can you please repeat this second last line, that Cp equals to 1.97 plus Cp?
Plus CP.
In the second
Which
last
one?
line, sir, in the second last line, you have written
Second
that
line.
Cp equals to 1.97 E plus Cp. That
That's
will be
CP.
Cp or that will be plus Cp or Cv here.
Which
In
one?
the second
This
last,
one?
sir,
Yeah.
So
the second last.
line.
Second last line, this is 1.987 plus 2.9805. Are you saying this one?
So
So
before
that's
that.
Before that.
2.98 is the value of which
Yes.
variable?
This is
Is
for CV. CV for monoatomic gas is 3 by 2 into R.
Yes, sir.
So 3 by 2 is 1.5. R value, as I've written, it is 1.987 calorie per mole per Kelvin. So if you are multiplying with 1 mole, mole and mole is getting cancelled. So you are getting only calorie per Kelvin. If you are writing with 8.314, then it is joule per Kelvin per mole. So if you multiply with 1 mole, again mole cancel. So you are getting joule per Kelvin. Similarly with liter atmosphere, if you are multiplying again with 1 mole, it becomes liter atmosphere per Kelvin. So I am here showing you all the three conversions with respect to each and every unit. Did you understand? Now
we are not
now
talking about the unit.
you are talking about this thing which I am showing in the cursor. CP equals
Yes,
to
sir.
1.
This is CP. CP equals to 1.97 plus CP. Sir, CP equals to something plus than CP.
Yeah, this is CP equals to R value. This is the R value 1.987, and this is the
Okay.
3 by 2 into R. So if you do multiply it 1.5 into 1.987, it becomes 2.9805.
Okay.
So CP value equal to 1.987 plus 2.9805, that is equal to 4.9. Approximately it is equal to 5. Similarly, if you are doing with joule per mole, it becomes CP equals to 12.471. Now I have to add the R value over here. So it becomes plus again 8.314. 8.314. So when you add together 12.471 plus 8.314, it becomes 20.785. It is now, it is joule per Kelvin. Did you understand?
Yes, sir.
Okay. Hello.
Yes, sir.
Hello.
Yes, sir.
Now moving further, can anyone tell me how to delete this one? So I think you have understood all these points. Now moving further, please delete all the whole thing. Thank you. So from here onwards, we move further on. Now, how to find out the enthalpy? If you want to find out the enthalpy, for example, the change in enthalpy, TH, and you want to find out the, for example, any numerical they have given you to find out the du. So how to find out the dH and du? For finding the dH, you will take the value of C. You have to take the value Cp. That's because we know that Cp equals to dH by dt. From here you can find out dH equals to, that is equals to Cp into dt. So I can further extrapolate this. It can become Cp, that is equal to, that is initial final temperature minus initial temperature. Now, if you want to find out the du, so you have to take the value of Cv. Cv equals to du by dt. From here, any numerical, if you want to do, then you can find out Cv equals to Cv into dt. So, what dt, further we can extrapolate this. This is Cv, that is given by T2 minus T1. So,
Again, we
in
could
this
not
way, you.
see anything.
सर कुछ दिख नहीं रहा
See anything? हाँ.
Can you see right now?
Yes, sir.
अभी दिख रहा है?
Yes, sir.
Can you see it?
Yes, sir. Yes, sir.
Okay. Now this is how you find out the du and Cv into T2 minus T1. This is why you have to use this formula. Now from here, if Cv value is not given, now if they are saying anything to find out the internal change for an ideal monoatomic gas, for example, they have given the value of Cp, but they have not given the value of Cv. For example, if I take numerical, suppose if I take one numerical over here, for example, if I take calculate, for example, if I take calculate the internal energy, or calculate the change in internal energy of a system which is undergoing an unidentified process from 45 degree centigrade to 100 degree centigrade. Okay, now calculate the change in internal energy of a system, which is the system contain 2 moles of an ideal monoatomic gas. Cp value is given. Cp equals to, for example, Cp value is given, suppose 12.471 joule per Kelvin. Can you do this one? Hello.
Last night, so I've got spent half the day travelling. I'm supposed to be gaining weight. I will let you in on a little info though. I just tried to do, but I think I'm okay. So I think I'm sitting quite heavy right now. What?
Can you hear me right now? Can you do this one? Calculate the change in internal energy of a system which is undergoing identify process from 45 degree to 100 degree. The system contains 2 moles of an ideal gas, and its Cp value is given as 12.471. Hello.
হ্যাঁ স্যার
Now, এই অঙ্কটা করতে হবে. Can anyone do this numerical? How to proceed if they are given this? Calculate the change in internal energy of a system which is undergoing an identified process from 45 degrees centigrade to 100 degrees centigrade. The system contains 2 moles of an ideal monoatomic gas. Cp value is given this much. So how do you start? So solution for this is, just check it out. I am doing for you. First of all, what I will do, I will utilize the Cv, that is Cv equals to, because I know the Cv equals to du by dt. From here, I can find out, taking this value, du equals to Cv into dt. So, but we don't know that what is Cv value. So, from the application, we know that Cp equals to,
Cp
here,
minus-
tell me, Cp minus
Cp
Cv
equals to R.
equals to R, and from this we can find out that Cv will be, because we don't know about the Cv, so you have to find out the Cv. So it will
Yes, sir.
become
And Cp is given.
Cp minus R equals to, that is Cv. Now here Cp is given, for that you have used this formula. Had the Cp not given, suppose they have removed this Cp. Suppose if they have removed the Cp, now this is
Yes,
one aspect. You are doing it because the Cp value is been given. Now,
Given.
if they remove the Cp, then how are you going to do? Then you will use the formula. Suppose this Cp is removed.
T2 minus T1.
No,
No,
then you have to use, this is because it is an ideal monoatomic gas, then Cv value will be straight away, it will be equals to 3 by 2 into
R.
R. Did you understand?
Okay, sir. Yes, sir.
Similarly, if they say that the same numerical, if I change this one with another numerical, calculate the change in, if I write over here, suppose if I write over here, calculate the, calculate the change in enthalpy of a mole of ideal monoatomic gas undergoing expansion from 50 degrees centigrade to 100 degree centigrade. Now you have to find out the, how can you proceed? Suppose this is the thing that you need to find out. So the solution for this is, now they have not given any, any Cp value or Cv value. So the, how to proceed in this, here given the T1 is how much? T1 equals to 50 and T2 equals to
100.
T2 equals to 100. So change it. I cannot write delta T over here, or
50.
dt equals to 50. Now, if you move further, it becomes, now how to proceed? They said that you have to find out the DH. So DH
Yes.
can be,
Cv equals
DH can be found out This is if you have the Cp equals to dH by dt. From here you can find out dH
dH
equals
is
to
equals to Cp into dt.
Cp into dt. So again, so
We have to find out enthalpy.
So
That
we
is,
need to find Cp. So,
we need to find
because it is ideal monoatomic gas, then we can use the general formula.
what will be the formula? What will be the formula?
we can find out Cp by Cb and R, and we know Cb equals to 3 by 2 into R.
But here they have not given any value of Cp or Cv.
Yes, sir, but we can find out by R value, by the value of R.
Now that is what I want to know. So how can any other participant who wish to answer this one? Say if you don't, if you keep mute, these are all marks related. You know there is an FC over here. I can see who is answering, who is not answering, who is participating, who is not participating. So
Hello, sir.
don't shout. I can hear you.
Sorry, sir. Sir, রাজনন্দিনী নেটওয়ার্ক এররের জন্য ডিসকানেক্ট হয়ে গেছিল, তো ও আবার জয়েন করেছে। আপনি কি ওকে একটু অ্যাডমিট করবেন?
Amijit, can anyone answer this question? Can all of you? Can anyone tell me what will be the solution for this? I have asked a question. This is suppose this is a question that will be asked in your exam or in your MPA. So calculate the change in enthalpy of a mole of an ideal gas, monoatomic gas undergoing expansion from 50 degrees centigrade to 100 degrees centigrade. So how do you
So
proceed?
we can find Cp by Cp is equals to 5 by 2R.
5 by
sir.
very good.
2R.
So
Yes.
you can so that is what Cp we said that Cv equals to 3 by 2 into R, and there are two approach, and Cp equals to 5 by 2 into R. This is for an ideal monoatomic gas. If you do not know this Cp value, what will be happening? So it will become, so Cp will become 5 by 2 is 2.5 into R value. Now, which R are you going to take? You know everything. If you are going to say calorie per Kelvin, because you multiply with 1 mole, then you can take 1.987, then it becomes calorie per Kelvin. Suppose I am multiplying with 1 mole. So mole and mole cancel. Now, if you are taking Cp value, that is equal to 2.5 into 8.314, then it is becoming joule per Kelvin. So by this formula, you can calculate this numerical. Therefore, if I
Which
go
value
to
we
the
will take
numerical,
in this process?
pardon,
Which value we will take?
that depends upon the question they are asking. If they are saying it one, if they are saying so, no. Now, which one you are going to take? Now, this is a very good question. Which one are you going to take? Let me understand. Which one are you going to take? You can take any one because they are given in degree centigrade. So you have to convert it into Kelvin. So you have to take any one of them. So because these are 50 degrees centigrade, so you have to convert this into Kelvin, and you can take any one of them. Now, provided the gas constant, the examiner, if the examiner asks you to give in the calorie per Kelvin, then you have to multiply with 1.987. If they say it with joule per Kelvin, then you have to multiply with 8.314. It depends upon the examiner how he twists the question. So I am giving you all the information so that you can do it properly.
Okay, sir.
Okay, up to this much it is over. Now let us move further. Is there any confusion up to this much?
No, sir.
Anyone? Any of
No,
the
sir.
students? Okay. Now moving further, so this complex here. Now moving to the Carnot cycle. Now, what is the Carnot cycle they are saying? The Carnot cycle deals with the. If you see the Carnot cycle, what does Carnot cycle say? Carnot cycle, regarding Carnot cycle, 2-3 observation. This Carnot cycle is a, first of all, it is a cyclic process. It is a cyclic process. Now, what is cyclic process? Can anyone tell me what is a cyclic process?
With any phenomenon that repeating, any phenomenon that keeps repeating.
No, in context of thermodynamics. In context of thermodynamics, is a cyclic process means what?
Sir, a process which goes from one state and return back to the same state.
Same state.
Then what is the work?
Sir, ds here ds will zero.
What is the work? What is the work? That means a walk started from a point, traveling in the same path. Suppose if I take, this is a pencil. Which one is a pencil? Suppose, oh, sorry. Suppose, oh, sorry. I am not habituated to this. Pencil का होता है? Okay. Suppose a cyclic process. Now this is the center. If you divide this into 3 portions, so here, suppose I divide this one, and then I take. Okay, anyway. So first of all, it is a cyclic process. The second point about the Carnot cycle is, it says that work, this is the most important point, work is equal to change in heat. So whatever the work is done, hello?
Yes,
Can
sir.
all you, whatever the work is done is equal to the change in heat. Work is change in heat. Now there are 4 steps in over here. One is, there are 2. Basically, thermodynamics is classified into 2 groups: expansion, and the other one is compression. Now, expansion and compression, if you put expansion under 2 conditions, at temperature constant, it becomes isothermal, and another condition, if you put as an adiabatic, it becomes an adiabatic. So the 4 steps are: one is isothermal expansion, then come adiabatic expansion, isothermal compression, and then come adiabatic compression. So if I write down the steps of the Carnot cycle, the steps are, this is one step is, first of all, it is isothermal expansion. Then the second portion, it is adiabatic expansion, and the third portion, this is according to this, it is isothermal compression, and the fourth process, it is adiabatic compression. What we get the end result of the Carnot cycle is, the end result is that we have to prove efficiency, that is efficiency equals to, that is efficiency is equal to Q2 minus, that is Q2 minus Q1, that is divided by W. So here it comes. Now again W is, I can write further this step. So I can write the rather further this step, efficiency, that is equal to Q2 minus Q1. Sorry, Q1, that is divided by Q2. So from here it comes that this is the this efficiency is again related with the temperature, that is Q2 minus Q1 divided by Q2, that is equal to T2 minus T1 divided by T2. And from here we enter the second law of thermodynamics, that is, it is called entropy of a system. Entropy of a system, which is equivalent to the randomness or degree of randomness. The significance of entropy is to measure, it is to measure the degree of randomness of a system. Degree of randomness of a system. From here we start the second law of thermodynamics. So you have to read the significance of second law of thermodynamics. You have to read why the second law of thermodynamics is required. Because the first law of thermodynamics, though it speaks about the W and the heat, but there is no the driving force from where the heat is coming and where the heat is flowing. It does not give the direction of the heat flow or the heat gain. It only says that heat stop or energy stop, no perpetual engine can function. But second law of thermodynamics put the limitation that only the perpetual machine you are talking. First law is talking about only perpetual machine, but what about the other factors? What about the other solids, liquids? Everywhere there is a thermodynamic feasibility study. You are assembling a computer system, there requires a thermodynamic feasibility study. There is a requirement of temperature. Wherever there will be a requirement of energy, wherever there will be requirement of temperature and pressure, there will be requirement of thermodynamics modules that needs to be calculated. Based on this preliminary investigation of the thermodynamics, mechanical thermodynamics has been established and mechanical modules has been established. If you see today, the different types of the instruments that are being produced depends on the all types of machines that have been produced is designed first of all for thermodynamic feasibility computer algorithm models. Now see, every time I say that nowadays any discipline is not a single discipline, it is always an interdisciplinary subject. So everywhere your subject comes in demand when you can fuse your knowledge with the mechanical engineering. For example, if you see now a few days, I'm just going out of the track for your knowledge. If you have seen, NASA has because of this pandemic issues, NASA has made a ventilator. How many of you know this? Hello.
Yes, sir.
NASA has made.
NASA has made a ventilator. I'm just going out of the topic, just for a few seconds. NASA made a ventilator. How many of you are aware of this fact? NASA is not habituated to make any type of ventilator. The engineers, they are the solar system engineers, the satellite engineers, computer or electronic engineers. But some of the engineers have made ventilators with the help of they have done a simulation model, and then based on the simulation model, they have devised a ventilator. Now, what is the feature of this beautiful ventilator is that because the patients cannot breathe cannot take the sufficient amount of the air, it forms the air even in the low concentration of the oxygen, and thereby it increases the partial pressure of the oxygen inside the body. Do you understand? So they have taken into consideration the solar system where the oxygen content is very low. Now, by the way, for a general knowledge, how many parts of oxygen are there in the atmosphere? How many parts of oxygen there in the atmosphere?
21%.
21.
Yes, sir, 21.
It is almost not 21, it is almost 23% of oxygen is present in the atmosphere. The rest are nitrogen, mostly nitrogen and other gases. So when we talk about the our atmosphere, biosphere, so oxygen content 23 parts. Let me take 23 parts of 100 parts. So if you go above from the biosphere, the oxygen content is getting depleted. So they have made a ventilator which is a computer simulated module and which can extract more amount of oxygen from the atmosphere. So this is really a great throw in the those people of the all are computer engineers with the mechanical engineers. They have devised a high throughput ventilator. It's called high throughput ventilator. So whenever I speak about the high throughput ventilator or high throughput machines, everything requires the thermodynamic feasibility study. Now coming back to your thing, this is more or less about the thermodynamics. Anything you want to know from thermodynamics? Or shall I end the chapter? Hello? Because I have completed the whole chapter, I think, very elaborately in the class. So I don't think so there is requirement to go through all these derivation. But you people go through the derivation. So whatever the derivation is there, first of all, the most important derivation is Cp minus Cv equals to R. We could not do because it is not possible to do the Maxwell equation over here. Maxwell equation requires a long process. If the time permits, then I will come back for the Maxwell equation. But we have done Kirchhoff equation. If I go through each and everything from the second law of thermodynamics, we have done Kirchhoff's equation. Now, what is Kirchhoff equation? Can anyone tell me? What is the Kirchhoff equation? Hello? No, what is Kirchhoff equation?
So delta
What-
H2 minus delta H1 by delta T equals to delta Cp.
What is delta? I am saying what is Kirchhoff equation? Kirchhoff equation is related to what? Kirchhoff equation is related to the ratio of change in enthalpy with respect to the change in temperature is equivalent to change in specific
CP.
capacity and constant pressure. It is also applicable for the change in internal energy with respect to temperature at constant volume, and that is at constant pressure is equivalent to Cv. That is the
Change in
change in
Cv.
Cv. Now, if you move to Joule-Thomson coefficient, what is the Joule-Thomson coefficient? What is Joule-Thomson effect? Joule-Thomson effect. What does the Joule-Thomson effect say?
Sir, if a gas is
This is a revision class.
suppose
so I'm saying.
allowed
Gas
to
is
allowed to pass from high pressure to
From a region of high pressure to a region of low pressure.
low pressure.
What does the gas show? It starts.
expands and starts cooling.
What does it
It
start? Let me
expands
know.
and starts cooling.
No, Anjali, you are very wrong. How does it expand? You are allowing it to expand. It does not expand by its own. Because you are passing the gas from a region of high pressure to the region of low pressure. So when it is passing from a region of high pressure, very small surface area, and when it is squeezed with a certain amount of energy to a very low area, it give a thrust. First of all, it give a thrust to the piston, and moves the piston and make its own space, and thereby it expands. So it does not expand. So there is no external force of expansion. It expands by its own. So, and that is why, and the most important thing about the Joule-Thomson that you people did not say is that it is carried out at constant Q. That means in adiabatic condition, which is again a hypothetical. It cannot be possible to completely do the thing in adiabatic condition to pass such a thing. Okay. So due to the constant Q, there is no change in enthalpy of the system, and due to which it starts falling in temperature and it starts cooling. This is the main thing of Joule-Thomson coefficient. So if you go to the derivation of the Joule-Thomson coefficient, already I have discussed. So it will become, now what is Joule-Thomson coefficient? It is constant, Joule-Thomson constant. Joule-Thomson constant is given by mu Jt. So it is equal to negative of change in enthalpy is a ratio of negative to the small change in enthalpy with respect to the small change in pressure at constant temperature divided by molar specific heat at constant pressure. So it is minus dH by dP at constant T divided by Cp. This is called the Joule-Thomson constant, mu Jt. Now, if we move further, we have done also, this is very important derivation, entropy change for an ideal gas. Now, what is entropy change for an ideal gas equation? You get three types of variables. So the first variable is given, if you do this, it is delta S equals to 2.303. Have you gone through this one? Delta S equals to, so I cannot write delta S over here. So I'm writing ds, actually it is delta S. ds equals to 2.303. What will be the formula? Two point three zero three C V log. This is log 10 T2 by T1 plus NR log 10 P1 by P2. Am I right? Am I right? Hello? Is it correct? Is this expression correct?
Yes. স্যার কিছু দেখতে পাচ্ছি না।
কিছু দেখতে পাচ্ছি না, স্ক্রিনে ব্ল্যাঙ্ক।
এবার দেখতে পাচ্ছিস?
হ্যাঁ
স্যার।
দেখতে পাচ্ছিস?
হ্যাঁ স্যার।
এবার দেখতে পাচ্ছিস? Can you all can see? Now ds equals
Yes.
to Cv log T21. Now this formula, are you aware of this formula? Okay.
Forgot.
Are you aware of this formula? So how many constant? So how many constant you can put? How many process you can put? One variables are T2 and T1. So this can be kept as a constant. Another variables are this one and this one. So pressure can be kept as a constant. And from here you can also put, if pressure is there, then you can also put the variables in terms of volume. So you get three types of process from this entropy change. One at constant volume, another is at constant pressure, and another is constant temperature. When it is done at constant temperature, we say that this small change in entropy with respect to isothermal process. Now when it becomes isothermal, only it will become, so at isothermal process, it becomes ds equals to isothermal process, it will become n r log V2 by V1. This is isothermal process. This whole thing I have changed. Now at isochoric process, uh, ds will become equal to now tell me at isochoric process what will be the formula? Hello. Hello.
Sir, wait, sir.
आइसोकोरिक में तो कांस्टेंट वॉल्यूम होता है इधर में
Okay, these are the things that you should bring. I don't have that so much of time. Now, what is Gibbs-Helmholtz equation? Can you tell me what is Gibbs-Helmholtz equation? What is Gibbs-Helmholtz equation? What is Gibbs-Helmholtz equation? Answer me. What is Gibbs-Helmholtz equation? What does it say? Gibbs-Helmholtz equation is given as that is delta G. So I'm writing, please write dG. This is delta G equals to dH plus constant temperature, third bracket. This is D of delta G. So I cannot write delta G. So I'm writing like this.
By delta
Divided
T.
by dt, and then you
At constant pressure.
so this is done at constant this is
Pressure.
done at constant pressure. This is what is called the Gibbs-Helmholtz equation. Now what is the significance of this Gibbs-Helmholtz equation? Next question comes, what is the significance of Gibbs-Helmholtz equation? Gibbs-Helmholtz equation. This is very important. What is the significance of Gibbs-Helmholtz equation? Can anyone tell me what is the significance of Gibbs-Helmholtz equation?
Sir, change in the Gibbs energy to its temperature.
DHDT.
What is the significance of Gibbs-Helmholtz equation? The significance. Now, if you want to write, I am giving you the answer. If you want to write, you can write it down. Shall I give you the answer? You want to write it down? This is very important question. What is the significance of Gibbs-Helmholtz equation for 2 marks? Shall I say you the answer? Or you are going to prepare by your own?
No, sir, say.
Okay, note down. The significance of Gibbs-Helmholtz equation are as follows. Right, quick. The significance of Gibbs-Helmholtz equation the significance of Gibbs-Helmholtz equation are as follows. Number one. It helps us Are you writing?
Yes, sir.
It helps us in better understanding about the force. It helps us in better understanding about the force that causes the chemical reaction to proceed forward. Number two.
So about the chemical reaction.
About the chemical reaction to proceed forward. About the chemical reaction to proceed forward. Number two, it tells the spontaneity and non-spontaneity of a reaction. It tells the spontaneity and non-spontaneity of a reaction. In the same line, after full stop, non-spontaneity of the reaction, full stop, then you write, if delta G equals to negative, the reactions are spontaneous, and vice versa. Furthermore, comma, if delta G equals to 0, the reactions are in equilibrium. The reactions are in equilibrium.
Some more.
In equilibrium. Written? Now, third point, from the Gibbs-Helmholtz equation also determines the spontaneity and non-spontaneity of a reaction or a process with respect to change in enthalpy. With respect to change in enthalpy. Full stop. If delta H is negative, reactions are exothermic, and delta G is also negative, that means reactions are spontaneous. I am repeating, if delta H is negative, the reactions are exothermic, then delta G is also negative, the reactions are spontaneous. Furthermore, if delta H is positive, the reactions are endothermic, and delta G is also positive, the reactions are non-spontaneous. Written? Hello, written? Shall I say?
Yes, sir.
Okay. Now, the fourth one.
Sir, please repeat. Delta H is positive, then reactions are?
If delta H is positive, the reactions are endothermic, and delta G is positive, the reactions are non-spontaneous.
Okay, sir.
Have you written up to this much? Have you written up to this much? Shall I
Yes, sir.
proceed? Okay.
Yes,
Now,
sir.
the fourth point. The equation also justifies the spontaneity and non-spontaneity of a reaction or a process of a system. The spontaneity or non-spontaneity of a process or of a process or a system by the following concept. A. By the following concept. A. If delta S equals to positive, write positive sign, then semicolon, delta G equals to negative, semicolon, reactions are spontaneous. I am again repeating. By the following concept. A. If delta S equals to positive, semicolon, delta G equals to negative, semicolon, reactions are spontaneous. The second portion, if delta S equals to negative, delta G equals to positive, reactions are non-spontaneous. Again, I am repeating the B. If delta S equals to negative, delta G equals to positive, reactions are non-spontaneous. Am I clear? Have you written the answer?
Yes, sir.
So this is all about the significance of Gibbs-Helmholtz equation. Now, coming to the further with respect to the physical significance of free energy. What is the physical significance of free energy? The next question is, what is the physical significance? This is another important question. With this, I will end the chapter. What is
significant?
I'm writing now, follow the board. What is the physical significance?
তো দেখতে পাচ্ছি না। আচ্ছা
এখন
ঠিক
দেখতে
আছে এবার
পাচ্ছিস না?
শুনছি। হ্যাঁ হ্যাঁ
এখন দেখতে পাচ্ছিস?
হ্যাঁ
হ্যাঁ?
হ্যাঁ স্যার।
এখন দেখতে পাচ্ছিস?
হ্যাঁ স্যার দেখতে পাচ্ছি এখন।
What is the physical significance? আমি বলছিও লিখছিও। What is the physical significance of free energy? What is the physical significance of free energy? Sorry. This is also for 2 marks. এরকম ভাবে পড়ানো যায় নাকি? কতক্ষণে কত কিছু পড়িয়ে দিতাম ব্ল্যাকবোর্ডে হলে। সে আমার ক্লাস চলছে, একটু পরে ফোন করো। হ্যালো,
Yes, sir.
ক্যান ইউ অল হিয়ার মি? এইভাবে পড়ানো যায় নাকি? হ্যাঁ, আচ্ছা বোর্ড হলে কত কিছু পড়িয়ে দিতাম। So I'm writing. So please write down the answer of this, and that will be the end of your thermodynamics. Shall I start? Say.
Yes, sir.
And from the next class, I will start acid-base equilibrium. and electrochemistry. Our Sadhu sir is completed. Our Sadhu sir is completed.
কেমিক্যাল কাইনেটিক্স এর জাস্ট স্টার্টিংটা করিয়েছে।
আমি কিছু নোটস গুলো আমি কিছু নোটস বোধহয় দিয়েছিলাম নাকি?
হ্যাঁ
থার্মোডাইনামিক্স এর নোটস দিয়েছিলাম না, দেওয়া হয়।
একটা পিডিএফ আছে মনে হয়।
ঠিক আছে। আচ্ছা, what is the physical হ্যাঁ আমি বলবো, তোরা লিখবি? Shall I say start writing?
হ্যাঁ স্যার বলুন।
From the first law of thermodynamics, we know Q equals to delta U plus W. Q equals to delta U plus W, where W equals to total work done by a system, where W equals to, that means you write equals to sign. W equals to total work done by a system. Work done can be of two types. Work done can be of two types. A, or Roman number 1, expansion work, or W in suffix you write expansion. Again I am saying work done can be of two types, namely expansion work or W expansion, and B, or Roman number 2, non-expansion work or W non-expansion. In the suffix you write W non-expansion. বুঝতে পেরেছিস? লেখা হয়েছে? লিখেছিস? ঠিক আছে। এবার নেক্সট লাইন, further comma, we know W expansion equals to PdV. We know W expansion equals to PdV or P delta V. Thus, the first law of thermodynamics can be rewritten as Q equals to delta U plus, thus first law of thermodynamics টা কি ছিল? Q equals to delta U plus W. এবার W হচ্ছে দুটো ভাগ, এক্সপানশন এন্ড নন এক্সপানশন। তার মানে আমি ওই ফার্স্ট ল অফ থার্মোডাইনামিক্স টাকে রিরাইট করতে পারি। I can rewrite the first law of thermodynamics as Q equals to delta U plus W expansion plus W non-expansion. And the next line I can write Q equals to delta U plus, because you have written 2 lines before, you have written W expansion equals to P delta V. Now instead of writing W expansion, you write P delta V plus W non-expansion. Have you got?
Yes, sir.
হ্যাঁ স্যার।
Written up to this much? That means Q equals to delta U plus P delta V plus W non-expansion. Further, we also know that delta H equals to delta U plus P delta V.
ডেল্টা ইউ প্লাস
P delta V. Delta H equals to delta U plus P delta V.
Yes.
Or delta H equals to delta U plus W expansion. Now you see this equation and the other equation 2 lines before equation, Q equals to, you have written Q equals to delta U plus P delta V plus W non-expansion. Now this whole factor delta U plus P delta V can be rewritten as delta H. So instead of writing delta U plus P delta V, I can write Q equals to delta H plus W non-expansion. Have you understood?
Yes, sir.
Now from next line, if you have written up to this much, the next line, from the definition of entropy, we know S equals to small q by capital T.
We know
We know S equals to q by T.
Q by T.
Now see what I'm writing. S equals to q by T, or delta S equals to dq by T, or delta S, you'll write delta S, ds equals to dq by T. Or from here I can write dq equals to T ds.
DQ equals to
TDS. Written up to this much?
yes, sir.
Yes,
Written
sir.
up to this much? Now come to this. The above. So after I say, you have to give some equation number. Otherwise, so if you see, we know that. Then you write. We know that Q equals to delta H plus W non-expansion. For small change in heat, this equation can be written as. Hello.
We know that. Yes, sir.
For small change in heat, we know that this equation, that means Q equals to delta H plus non-expansion, this equation can be rewritten as dq or delta Q equals to delta H plus W non-expansion. Now we know that delta.
স্ক্রিনে কিছু দেখা যাচ্ছে না কিন্তু
কি দেখা যাচ্ছে না?
মানে আপনি যদি কিছু লিখে থাকছেন এখন শো হচ্ছে, ঠিক আছে?
হ্যাঁ স্যার দেখেছি।
কি লিখেছিস আমাকে একটু বল। কি লিখেছিস? কি লিখেছিস?
Can be
So for a
rewritten
small
as
change in heat, we know that this equation can be rewritten as
Delta Q equals to, can be rewritten as delta Q equals to delta H plus W non-expansion. এবার delta Q এর জায়গায় লিখবে T delta S equals to delta H plus W non-expansion, or minus W non-expansion equals to delta H minus T delta S. একদম সিম্পল লিখেছিস। T delta S মানে T E S, that is equals to DH, আমি DH লিখছি প্লাস W non expansion।
ঠিক আছে, লিখেছি।
তার মানে এখান থেকে হবে মাইনাস W non expansion equals to DH minus TDS। মানে তোমরা লিখবে delta H minus T delta S। We further know that the delta G equals to, I mean DG DH minus T DS. We further know that delta G equals to delta H minus T delta S. Now comma minus W expansion non-expansion is equal to delta G. So therefore minus delta G, that is minus delta G equals to W, because work can never be having negative sign. So I am removing the negative sign from W and putting it to minus delta G equals to
W non-expansion.
W non-expansion. this proves that the last line. This proves that the W non-expansion is equivalent to useful work. This proves that W non-expansion is equivalent to useful work, and thus, if delta G is negative, the work is continuous. Thus, if delta G is negative, the work is continuous and is attributed as
The
useful
word
work.
is
This proves that if delta G is negative, the work is continuous and is attributed 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 as useful work. ঠিক আছে?
হ্যাঁ স্যার
Okay, now it's 6 o'clock. Shall I end the meeting? So this completes all of your thermodynamics. After this, by today evening, I will be posting assignment question. I will be posting assignment question in the Google Classroom of your F1 batch. Please check it out, and I will let Rajrupa to once I post the same. Once I post the same, then I will let Rajrupa and she is going to inform you. So students, we have made a schedule. I think Rajrupa is going to give it to you on Sunday.
Saturday sir.
Saturday. We have made a particular schedule. If all the students are listening, then I can just brief you, which is Rajrupa is going to give it to all of the students. For this week, we will be having the schedule something abruptly changed, but from the next week, we have a definite schedule and the classes is going to happen in that time only. If there is any problem with logistic support by any faculty, the classes may get changed. So, in that case, this will be properly intimated to the CR of the class well ahead before any problem persists, or well ahead before the class starts. Have you heard? Have you listened everything? What am I saying? Now, today you had the class from 4 to 6. I made it from 4:30 to 6. And today at the same time, from 6 to 8, Sadhu sir is going to take the class of F2. And tomorrow, from 6 to 8, he is going to take the class of yours, and I am going to take the class of F2 from 6 to 8 at the same time. Now, coming to your routine.
I ask him to do from about 6:30. 6 to 8 is not possible for me.
That will be let known by Rajrupa. She is going to talk to Sadhu sir, and from 6:30, no problem, from 6:30 to 8. But he cannot teach more than 8 o'clock. Okay, so this is for this week, Thursday and Friday. Now, students, you have chemistry as a subject of 4 credit. That means when we make the routine with your CR, taking her into the conference, when we make the routine, we consider that the credit system, because in a week you get 4 classes from the chemistry department for the subject chemistry. 2 classes is taken by myself, and the other 2 classes is taken by Sadhu sir, if you recollect. Am I right? Am I
Yes
right?
sir.
Okay. Now the same thing is also going to happen over here. Now, if you remember that every class of yours was in that offline system was 50 minutes. So 2 period, 50 plus 50, 100 minutes. But now here we have made together in one day, we are going to complete it for 2 hours, 60 minutes plus 60 minutes, 120 minutes. That means we are giving maximum 20 minutes more. And that is from the point of log in to the end of the meeting. So 20 minutes is kept because the students are going to come inside the room, participate, and 20 minutes buffer time has been kept so that you get the opportunity to enter. 20 minutes I think is more than sufficient. Once the 20 minutes is over, the faculty is going to log the meeting and the meeting is going to end after the scheduled time. So accordingly, we have made the your timetable. For example, Wednesday, you are going to have your scheduled class from 4:30 to 6:30 by me. I will be taking the class. Friday, you will be having the class from 6:30 to 8:30 by Sadhu sir, and that completes your full class schedule. Am I clear to all of you? So Wednesday and Friday, you will be having the chemistry theory. And regarding the practical, it has been decided by your CR along with the practical madam that your practical batch is going to have 3-hour classes. So 3-hour classes is, first of all, they will be having the class on Monday. Am I right, Rajrupa? Monday, the class will start from 11 to 12.
12:30, yes, sir.
Oh, sir, 12:30. And Tuesday, it will be from 12:30 to 1:30. So you are going to have 2.5-hour classes. So Monday and Tuesday, your chemistry practicals finishes. And it will be taken by Priyanka madam. Have everyone understood?
Yes, sir.
Obviously, it will be given by Rajrupa. Okay. Okay, thank you. Rajrupa, কোথা থেকে এন্ড করবো এটা?
ওখানে দেখুন স্যার এন্ড মিটিং বলে অপশন থাকবে নিচে যেখানে আপনার মিউট বা ভিডিও